All right, welcome. This is the practice questions for Precal Learning at Home. You should have already gone through the warm-up and the direct instruction videos. These are just if you're getting stuck or if you want to do a little bit more explanation for the practice, that's what this is for. So this is the first practice question. It says that we have a vector A and a vector B, both of which have the same direction. So the direction tells us the angle. You can think of it like an angle from a standard position. A has a magnitude of 8, B has a magnitude of 5. Magnitudes don't really matter here, we just know that they're different. What must be true about A and B? Okay, so if you read the answer choices, it says they are opposite and parallel. We know that they're not opposites because they're pointed in the same direction. Answer choice A, I drew what that would look like if they were opposites. That's not ours because we know they're going in the same direction. Answer choice B says they are parallel but not equal. And that is true. As you can see, the two lines that we have here representing the vectors for A and B are parallel to each other, but they're not equal because A is 8 and B is 5. Obviously not drawn to scale, but they are differently. Answer choice C, they are equal but not parallel. They are parallel, so it's not going to be answer choice C, and they're obviously not equal because it tells us they have different magnitudes here, so it's not answer choice C. Answer choice D, they are opposites. They're not opposites. They're pointing the same direction, so they're not going to be opposites either. So it should be answer choice B for this one. On question 2, it asks us to see if we can find the difference between 2 of vector A minus 2 of vector B. And you literally can copy and paste exactly what it tells you to do. Take a vector A right here and make 2 of them and add them together. So there's 2 vector A, multiplying it, it's going to be twice as big in the same direction. And then subtract 2 of vector B. And when you subtract a vector, you literally just go the opposite direction. So if B is going this direction, when you subtract B, it should be going the opposite direction. So from the endpoint we came up with here, if we subtract B, we end up getting minus B here, or minus 2B. So the resultant vector should be 2A minus 2B. And that does look like exactly like the less colorful diagram for answer choice A. On question 3, it says Belkis is pulling a toy by exerting a force 1.5 newtons. Basically, we have a diagram that we've drawn here. I'm assuming it's a dog up here that is pulling a toy from a rope. This line here is representing the rope. Whoops. This line here is representing the rope, obviously the toy, and the dog is pulling it in this direction. So the question is asking what would the vertical and horizontal components be? Literally all we need to do is figure out the 2 sides of a right triangle using trigonometry. We can use sine, cosine, and tangent, in this case sine and cosine, to figure out the vertical component y and the horizontal component x. And those would be straight in the north direction or in the east direction when we're done. The y value represents north, the x value would represent the east direction. So if you wanted to solve for y, that is the opposite side from that 52-degree angle, we could use the opposite side and the hypotenuse to represent the sine trigonometric ratio. So to solve for y, we know sine of an angle equals opposite over hypotenuse. And if we plug in the pieces, sine of 52 degrees equals y over 1.5. If you multiply both sides by 1.5, we get the y value equals 1.5 times sine of 52. Obviously, at this point, you would need to make sure your calculator is in degree mode. When you plug that one in, you should be able to make sure that you do get the north component is approximately 1.18 north. Same thing for the x values. If you recognize this is the adjacent piece, we could use the adjacent and hypotenuse to solve for the horizontal component. We use the cosine ratio. Adjacent over hypotenuse, plug in our pieces. X is going to end up equaling 1.5 times cosine of 52. Same thing, you plug in the calculator, make sure it's in degree mode, and we do get approximately 0.92. So should be answer choice A for this one. Notice this right here is exactly what we did for the trigonometric section when we first started learning about how to solve for the x and y values on unit circle. 1.5 times sine of 52 gives us the y component right here. So this is the sine, y is the sine values, x is the cosine values. 1.5 times cosine gives you the exponent. 1.5 times sine gives you the y component. Useful in the next problems we have coming up. On question 4, it says, which of the following correctly displays vector s plus u? You literally just add them end to end. I tried to draw a copy of vector s right here, about the same length, same direction. If you add u to the end of that, tried to represent u right here, add u to the end of it. This is the final point, so you get the resultant vector here, s plus u. Looks a lot like answer choice D. Pretty sure that's the answer you're looking for. The answer choice D. Adding is literally you add it end to end to end and see what you come up with. Number 5, find the magnitude and direction of 3s. So adding, you would need to find the endpoints, and if you have vectors that are in different directions, there's going to be you end up with a direction that's completely different. So unlike that last example we had s plus u, and we ended up getting a completely different direction than either of the other ones. When you multiply something, you literally just keep going in the same direction. So, you know, like if I had r, or whatever you want to call this one, 3r is going to end up looking like this in the same direction. So we're not going to draw a picture of this one. We just need to multiply, and we know the direction or angle is not going to change for this one. So if s right here is 1.4, then 3s would just be 3 times as far, which is 4.2. It says we have a 45-degree angle, so the new one is also going to be 45 as well. All you do is multiply. So 3s is 3 times as far in the same direction. Nothing changed when you multiply. I guess that's answer choice A. All right. Last one for this video. A little bit of explaining to do on this one. It says find the magnitude and direction of vector r plus vector s minus vector u. So notice I drew a little diagram already to represent, here we have r, and then we're going to add s to it. And if we were adding u, u looks like it goes down and to the right down here. So if I was adding u, it would look like it was ending up down here. Subtracting it, you just go the opposite direction. So I went ahead and drew a solid line. Looks like it's going to eventually make some sort of vector that goes like this. So just using a little bit of common sense, we know that, okay, maybe it's going to end up, you know, being somewhere around a little bit more than 90 degrees, probably 133. It looks like are some answer choices that we got. We just want to make sure that we know how to do these in case it's not as obvious or if we don't have answer choices. So the easiest way to do these is to break it down individually into their vertical and horizontal components. So let's start with, I'll start with the easiest one, S. If I have a vector S that has a magnitude of 1.4 and at 45 degrees, all I really need to do is figure out the vertical and horizontal components of that. And normally we represent them with X and Y values, so I'll go ahead and do that as well. We have a vertical and a horizontal component here. All I need to do is solve for them. Hopefully you learned in geometry and trigonometry, it's real easy to solve for these using trigonometry. We can use the sine value to find this opposite side, or the y. 1.4 times sine of 45 degrees will give me the y value. And I can also find, oops, should have done that in the other color. Okay. And 1.4 times cosine of 45 will end up giving me the x value. If you type those in your calculator, make sure it's in degree mode, and you should get some answers that do make sense. Should be obviously the hypotenuse here is 1.4, so they should be less than that. If you're getting something that's negative, both of these should be in the positive direction for x and the positive direction for y. So it might be in radian mode if you got a negative answer or something that was bigger than 1.4. In any case, if we type them in our calculator correctly, we should get 0.99 for each of these because it is a 45-degree angle. Both of these actually happen to be, it's an isosceles right triangle, so we do get 0.99 for both of these. So for S, vector S, the x component ends up equaling 0.99, positive 0.99, and the y component also equals 0.99. If you do this for the other ones, let's do R. That should be an easy one. For the vector R, I guess I'll do it over here. To get your x value and y value, let's start with x. X is going to equal 2.6 times cosine of 128. And your y value equals 2.6 times sine of 128. When you plug those in your calculator, we do end up getting that the resultant vectors for x and y, negative 1.6, makes sense. It is in the negative direction for x there, and our y vector should be 2.0488. The last one, you can do your resultant vectors for W, the vertical and horizontal, and then just make them both negative. Whatever x value you get and whatever y value you get, you'll just do the exact opposite. You'll get the opposite x and the opposite y for this one. So I guess I could do this one here. You do it the same way. You should get the, whatever values you get, just make them opposite. So if you did u, you should get x equals 2.82, and y equals negative 1.026. So I'm just going to use the opposite ones for both of these when I subtract u. So the x value for subtracting u will be negative 2.82, and the y value will end up being 1.026. So now, well, we ran out of time.